Hello everyone, once again welcome to your channel, welcome to your favorite channel, that is TKG Physics Classes. So students, I think this is our lecture number 8 or 9, and in this lecture we will solve the equation of motions by graphical method. We already completed, we already derived the equation of motions by general method, and we derived the equation of motions by calculus method. Now today we will solve it by graphical method. So students, if you don't watch the previous video, if you miss the class, that is a solvation of equation of motion by graphical general method and calculus method, you just tap anywhere in your mobile screen, you just see there is an I button and link are given, go and watch it. So first of all, you have to know, in previous class we derived how to draw a graph. We draw various graphs in various situations. We draw velocity time graph for uniform motion. We draw velocity time graph for uniformly accelerated motion. Here, for solving the equation of motions by graphical method, we need a graph, because this solution is by graphical method, and the graph is this one, the velocity time graph for uniformly accelerated motion. And you know, for uniformly accelerated motion, the velocity time graph is represent the straight line. Here a body is moving in a straight path, velocity time graph with some initial velocity u, and at point B there is final velocity, suppose this one final velocity v, and you just think at origin time 0 and at point E the time is represented by t. So this is the velocity time graph for uniformly accelerated motion. So first of all, you write down this form, which is represented by OA. By graph we can write OA, that is equal to this one. OA is similar to DE, so OA is equal to DE, and that is equal to initial velocity u, this one. Now what is represented by OC? O to C, this is the final velocity, and OC, this portion O to C is exactly similar to B to E, so write it down. OC is equal to B to E, that is equal to final velocity u. Now next, what is OE? OE, that is exactly similar to AD, this portion AD is exactly similar to OE, and here E is represent T and O point is represent the initial time, that is 0. So OE is equal to AD, that is equal to T. Now solve the first equation, and the first equation is U is equal to V is equal to U plus AT. You know the equations, and you know the formula behind it, how to solve, how to find out the acceleration from this graph. Just in previous class we discussed, we already completed how to solve the acceleration from velocity time graph, and the solution is we have to find out the slope of this velocity time graph. So write it down. The slope of VT graph, that is represent acceleration. And what is the value of acceleration? You know that suppose this angle is theta, so that means slope, that is equal to tan theta, and this value gives perpendicular by base. So here perpendicular is BD and base is represented by AD. Then again write it down, that is acceleration A suman BD. You just think, what is BD? If I write BE minus DE, then it's represent BE minus DE, then it's represent BD, this portion. So B, in the place of BD you can write BE minus DE. And what is AD? Just think AD is exactly similar to OE, so write it down, that is OE. So this equation becomes A equal to BE, just think BE, that is V, DE that is U, and OE, that is T. So the solution is V minus U is equal to AT, V minus U is equal to AT, then V is equal to U plus AT. Okay, so very easy. You just draw the graph, velocity time graph for uniformly accelerated motion. Then from this velocity time graph you find out the slope. The slope will give the acceleration, and you know the acceleration value, that is change in velocity by time interval. So by solving we can get v is equal to u plus at. So this is the solution for equation of motion, first equation of motions for uniform acceleration. Mind it, this is the equation of motion only for a condition when acceleration is uniform. Okay, now second equation, solve second equation, and you know the second equation, that is s equal to ut plus half at square. Write it down first. Second equation, s is equal to ut plus half at square. Same thing, you just think how to find out s, distance, by graphical method, by graphs. We already discussed in last lecture. That is, we have to find out the area under velocity time graph. The area under velocity time graph is represent distance. So write it down, the area under velocity time graph, distance s is equal to area under vt graph, and here area, that means area of trapezium, this one a b e o, a b e o. Now the area of trapezium, that means area of rectangle, this one a d e o, a d e o, plus sum of this portion a b d, that is the area of triangle, a b d. Now just write down the formula for rectangle and triangle, you know the formula. So s is equal to area of rectangle, that means length into breadth, that is OE into, that is OA, plus area of triangle, that is half, into base into height. This is base and this is height. So base is represented by AD and height is represented by BD. Now just putting the value, what is OA? OE, just see, OE is equal to T. What is OA? OA is equal to initial velocity u. So this is ut plus, there is half. What is BD? Just this one BD, this total velocity v and this portion initial velocity u. So BD is represented by v minus u. So write it down, v minus u. And what is AD? AD, just think AD, that is equal to T. So write it down, this is T. So S is equal to, S becomes ut plus half v minus u into T. And you know what is acceleration? A, that is equal to v minus u divided by T minus 0. So v minus u is represented by at. Just putting this value in the place of v minus u, you can write at. So put it down, that is S equal to ut plus half, in the place of v minus u we can write at, and there is another t. So the equation becomes S equal to ut plus half a t square. This is the proof for second equation of motions, that is represent the distance time relations. Or you can say, if we write S equal to x minus x naught, then we can say this is the position time relation. So nothing else, you just have to find out the area under velocity time graph, all because you already known this part, that is the area under velocity time graph is represent distance. Okay. Now final third equation of motion, that is v square is equal to u square plus 2as. Write it down first, v square is equal to, equation 3, v square is equal to u square plus 2as. How to solve these equations? You just think there is an s represent distance, and distance, that means s, that means area under vt graph. Now here in the place of area under vt graph, you can write the area under same thing, the trapezium ABEO. So write it down, that is area of trapezium ABEO. Now here you write the formula of trapezium, that is half into sum of the parallel side into the separation between them. So here parallel side, that means this one OA and this one BE, that is sum of the parallel sides BE plus OA into the separation between them, the separation between two parallel sides, the separation represented by this one. This is the separation between two parallel sides, that is OE. So in the place of separation you can write OE. So this is the formula for calculating the area of trapezium. Now you just think acceleration A is equal to this portion BD divided by this one AD. Now in the place of BD you can write BE minus of BE divided by, in the place of AD, this one AD is just equal to OE, so you can write this one, right? And in the place of BD, this portion, total portion difference minus of this portion. So you know what is DE. DE is represented by OA. So what is OE here? OE becomes BE minus OA divided by A. Just simplify. Now you know the value of OE. Just putting this value in this equation, that is half into BE plus OA, and this one becomes BE minus OA divided by A. Now putting the value half into, what is BE? BE is equal to V. What is OA? OA is equal to U, that is V plus U, and you just think this one is V, this one is U, that is V minus U divided by A. Just solve it. So 2AS is equal to, there is an in left side S and in the right side downward there is a 2A, then cross multiply, that is 2AS is equal to this V plus U and V minus U. So this one becomes V square minus U square. So the final equation becomes V square minus U square equal to 2AS. So from here we can say V square is equal to U square plus 2AS. This is the third equation of motions for a uniform acceleration. And the solution method, that is same. You have to find out the area under VT graph. Then in the place of OE, that is the separation between two parallel lines, you just putting the value, this concept, that is you express OE in terms of V minus U, and there is a V plus U. Then in the place of OE, putting this value and simplify it, the answer becomes V square equal to U square plus 2AS. So students, this is all about the equation of motion by graphical method, and I think all of you like this video, all of you known on this part about. So today I completed here. Till then, bye bye, stay happy.